Good morning, grade 6. Okay, so you're in the file for today. I brought an important notice. These teacher videos, the one you're watching right now and the ones from before, they're the most important part. And some of you are not watching them till the end. So that's the note I put here. And how do I know you're not watching them? Because your worksheets show, the work that you're doing shows that you did not listen to anything I said. So please watch them till the end. So for today, you're going to be learning about energy transformation, conservation of energy, and energy systems. I know some words sound kind of confusing. We're going to learn about it now. So you should have watched video 1 by now. They're from YouTube, and video 2, and now you're in the teacher explanation. Okay? When you're done, you're going to be watching, you're going to be doing worksheet 2. Okay, be careful. Worksheet 2 is 2 pages, not just 1 page. It is 2 pages. Okay, please be careful. All right, now these are the slides for today. Let's talk about the slides. Okay, so energy transformation is not like energy transfer that we took yesterday. Okay, it's not the same thing. Energy transfer, okay, is when the same kind of energy is being transferred from one place to another, but it's the same kind of energy. Energy transformation is when the energy turns into a different kind of energy, so into another form of energy. Okay, let's look at it over here. Look at these examples. So this apple is food. Food has chemical energy in it. Okay, when the man eats the food, he's converting the chemical energy and he's using it to move on the bike for mechanical energy. Electrical energy here is transforming into light energy. Now, light energy is like electromagnetic. It's a kind of electromagnetic energy. Okay, they didn't write electromagnetic here. They wrote light, but it's a kind of electromagnetic. Okay. Same thing here. Light energy from the sun is being absorbed by the plant and turned into chemical energy in photosynthesis. Chemical energy inside the battery is turning into light energy. Chemical energy from petrol and fuel is turning into mechanical energy in the car. Electrical energy here is turning into heat or thermal energy. Chemical, same thing, food and motion. Motion is mechanical energy. Radiant, which is light, chemical, same thing. Electrical here is turning into thermal. So energy transformation is when one energy turns into another kind. Okay, another kind. It's different from energy transformation. I made this slide to show you the difference. Energy transfer, same kind. Energy transformation, okay, from one kind to another kind. Here, it's just the same kind, but it's moving from one object to another. Okay? Energy transformation from one kind to another. Here, one object to another. One kind of energy to another kind of energy. So there is a difference, and they are not the same. These two words are very different. They're not the same. And you need to remember that, because most of the things that I'm going to bring in worksheets and later on quizzes and Nearpod quizzes are going to be about this. So make sure you understand it very well. There's another kind of energy transformation. It's basically when energy transforms from potential to kinetic. So if you're holding the ball over there, it has potential energy. It's not moving. So potential energy is energy, okay, that's waiting. Remember that. It's energy that's waiting, and kinetic energy is energy that's moving. Remember that from the first lesson that we took. So here, when you're holding the ball, it's potential energy. When you let go of the ball and the ball falls down, it transforms. See, there's a transformation from potential to kinetic energy. And this is a kind of transformation, okay, from potential to kinetic energy. Okay, this is gravitational potential to kinetic. Now, if the ball was here, okay, and let's say the ball was here, which one do you think has more potential energy? And the one that's up. This ball number 1 has more potential energy than ball number 2. Because it's higher. The higher an object is, the more potential energy it has. Okay, that's another example of potential kinetic becoming potential and then potential becoming kinetic. Look at this. The car's over here, it's moving, it's kinetic. It's going up the hill, it becomes potential when it stops here. And then when it goes down the hill, it becomes kinetic again. So here it's moving. Here it stops, becomes potential. Here it's moving again. So kinetic, potential, kinetic. Another example, gravitational kinetic, the water here, okay, is potential. When it goes down, becomes kinetic, moving. Up here, it's potential, down, it's moving, kinetic. Okay, now the second thing we're going to learn about today is the law of conservation of energy. Conservation is when something stays the same. Okay, you got to remember this word. Conservation is to keep something the same. I'm going to write it in a better way. Hold on. Conservation, same. Okay, now there's something you need to know. Energy is never, so the law of conservation of energy tells you that energy stays the same. What does that mean? Energy is not created or destroyed. You can never create energy. You can only transfer it, or it can be transformed. Okay, it can never be created or destroyed. Never. Now you watched a video about that. It's video 2, energy conservation. I hope you watched that video. It tells you that energy is never created nor destroyed. It just moves around from one system to another, from one place to another. It transfers, it transforms. Look at here, it's transferring, here it's transforming, but it's never, never, never created or destroyed. That's the law of conservation of energy. Sometimes you have energy loss in systems, but they don't completely go away. They just become something else. Like here, you have potential energy here. Okay, if it's, wait, hold on. Potential energy is in the one that's not moving. So this one, let's say, has potential energy. This one is moving, it has kinetic energy. Okay, now when it hits here, okay, the energy is transformed to mechanical and it starts moving. But you know, some of the energy goes into its sound. You know, you can hear it move. You can actually hear this. And some of it goes into thermal. This becomes a little hot because it's moving and touching each other. So some energy, we call this energy lost. So the mechanical energy is going through sound, becomes sound and thermal. Okay, so it's not destroyed, it's just lost into something else. Okay. Last thing we gotta take about is energy systems. All right, look at this. Energy systems, this is an energy system, okay? You have light energy, and it's coming to chemical energy. Now, in the system, we call it, there are inputs and outputs. Inputs means what goes in, and output means what goes out. So input here is electromagnetic, which is the light energy. This is electromagnetic. And the output, what comes out, is chemical. Okay? So this is a system. All of this is called an energy system, where we have something going in and then something coming. I'm going to make this at a better arrow. Something coming out. So in and out. Input and output. Okay? Input and output. All right? Energy has to be put into a system. That's input. So how's the energy being put here? Through the sun. It can be transferred, it can be transformed. So here it's being transformed from light to chemical. Results or outputs are produced. The output is chemical energy. Okay? That's another example. This is a dam. This is a dam. Okay? The water goes through here. Okay? When it goes through here, it moves, okay, something inside there, and this is mechanical energy, and this mechanical energy creates electrical energy. Okay, so these dams can create electricity by moving some blades inside here, okay, which cause them to create electricity. So the input here is mechanical energy, and the output is electrical energy. Okay? Congratulations! Why am I saying congratulations? Because you reached the end of the teacher explanation video. That means you got a +1. And how will I know that you got a +1? You're going to write the secret word, okay, on Shobi for me, and this will show me that you've watched the whole video. Now the secret word is this. Secret word is bunny. Okay, I'm gonna write it again in a better way. Secret word is bunny. Okay, now you write bunny. Don't write this on the class discussion. Write it for me alone on Shobi. When I see this word, I know that you've watched the whole video. You get a +1 on all your assignments. Like, I will, not all of your assignments, I will distribute the +1 wherever you have grades that are lower. So let's say, and someday you have 4/5, I'll make it 5/5. So I'll go back in and fix your grades and add a +1 wherever you need it. Okay, don't tell anybody about this. They have to watch the video, reach the end until they get the secret word. Okay, so write bunny for me on Shobi. All right, so I know that you've reached the end of the video. Okay, thank you for watching it all, and you should always watch the teacher explanation videos until the very end. Thank you. And this is the end of the lesson, by the way. We're just going to have worksheets. There's no more explanation.